that's a TRX with an adulator bucket, and I'm just comparing it to a Mach II, which is basically the same tractor except on the back it's got the rubber tracks. Same sleek styling, of course. Makes it go faster. And here's the adulator bucket. So what I'm discussing is how we add ballast weight, because the more weight you add there, if you add too much weight, obviously this end wants to come in the air, so the logical thing to do is to add extra weight this end if you need to. Probably don't need to though, generally speaking. But if you want to, you can put extra cast weight. There's 3 weights that stack up here. And because that's a long way out from the axis point will be the centre of that wheel there, a little bit of weight has a big effect. Now the only problem with putting weight there is that when you put down pressure, such as this situation here, so you push the bucket down to make it push into the ground, you want as much weight here as possible, because that's the weight of this end of the tractor is what pushes that into the ground. And weight there actually makes that lighter, because this is the axis point. So what you may be better off doing in that situation is, instead of adding weight there, add your cast wheel weights there, because that gives you the benefit, you know, increasing your capacity here, but it doesn't decrease your downward pressure. Okay. Now the other thing to consider with a Mach II is that a Mach II weighs approximately 750 kilograms heavier than the wheeled version, and all that weight, as far as I can tell, is just in the track mechanism, or, you know, track and final drive possibly, but it's all in this vicinity, you know, in line with the centre of the wheel. So that extra weight here, extra down pressure here compared to here's only got a little bit of weight, it gives you extra digging capacity, extra down pressure on your bucket. It's going to make, you know, 750 kilos there is going to make a massive difference there. And I mean, even with the wheeled version, you've still got pretty impressive digging power there. But that's just even more impressive again. Now the other thing with comparing the wheel and the track, if you do overload it to the point where this end comes in the air, it's going to go in the air. The height that it goes into the air depends on how high you lift the bucket. So if you lift it right up, it's going to come quite steep. It's never going to tip over doing that, not straight forward, you know. Maybe if you're on a ridiculous sideways angle as well, but if you're on level ground and it tips up like that, it'll only come down to the bucket that sits on the ground, because that's about as high as the bucket goes anyway. So you can control it with that. If you want it to come back down here, you just let the bucket down, you know. And in that situation, then you can still manoeuvre it with the turning brakes, but your bucket is skidding on the ground, you know. It's not going to have a lot of weight on it, because it's going to be sort of near the balancing point anyway. And you can still manoeuvre where you want to go, skidding around with your turning brakes. The big, and when it tips up like that, there's the axis point, centre of the wheel. With the Mach II, if you overload it in the bucket, and if you haven't got extra weight up this end, and that does happen, remembering, you know, in most situations you're not going to ever get to this point, but let's say you've got some extreme weight in the bucket, maybe you've got the tooth bar on there which extends that out and allows you to fill the bucket a bit more, depending on the material. And let's say you're reversing up a hill, and if the wheels come in the air, normally sitting on the flat ground, the axis point on these, as far as I can tell, is there, because this mechanism is all fixed to the final drive housing, and the mechanism that goes out to these rollers pivots there, so that's therefore is the axis point. It's got 11 degrees and 8 degrees movement, and that's the axis point, whereas the wheel tractor, it's up higher. But once it tips, you know, runs out of that 11 degrees, which mind you can reduce if you want, so this end of the tractor will lift up 11 degrees before it reaches the stopper, and then the axis point moves from there to there. So when that's your axis point, your weight becomes a lot more effective, you know, because you've got a lot more weight from the axis point out to here than you have from here out to here, or even here. So as soon as it reaches the stopper, you know, it multiplies your weight. And when that happens, you know, it's only going to come up till it sits on the stopper. Your bucket's not going to come down and touch the ground, and you've got a lot more controllable situation, and you can just drive it like a skid steer then, just use your turning brakes. And that's going to be a big advantage, having the tracks over the wheels in that situation, as well as also the extra weight, the penetration.